welcome back to another video of Quick and Nerdy. As always, I'm your host, Brandon McCoy, Technical Advisor at Veeam Software. I'm located in Atlanta, Georgia, and I support our Veeam Cloud and Service providers. As you can see from the title, today's video is going to be on the Hardened Linux repository. We're definitely going to go through the lab and set it up, show you the commands you need to run, how it's done. But I think first we're going to need to talk about what a hardened Linux repository is. You may have heard this word on a demo or read a white paper, so I think it's important to start there. So it's time to come to terms. So a hardened repository with Linux is a two-part process. The first is we need to use single-use credentials. So these are credentials that are stored only once to deploy our services so that we can make this Linux server a Veeam repository. These credentials are not stored in the Veeam database, so backup files will be safe, even if the Veeam server is compromised from an internal malicious employee or an outside hacker. Once those credentials are safe and secured, we call that hardening the repository part one. Then we make the backups immutable. So immutability is making sure that backups cannot be deleted, modified, encrypted, etc. So when you add a Linux repository, all you have to do is check a box to make the backups immutable for a specific period of time. And now this Linux repository is hardened, it's ransomware proofed as much as it can be, and you should sleep a little better at night. Now, before we jump into the lab, I do want to talk about Linux itself. A lot of people aren't very, well, I shouldn't say a lot, but if you're like me, you may not be very comfortable with Linux. I've learned a lot just from doing these hands-on labs and creating these videos. We are going to be running a little bit of Linux command today, but I don't want that to scare you. If you look here, we can see the Windows versus Linux and what those Linux commands are, right? Like the rescan is just rescanning disk. We're going to create a partition. We do need to format our file type as XFS, so only Linux server versions support this. Just like with Windows, we always recommend a REFS or Resilient File System repository, and only Windows Server Edition supports that. So the XFS, the ref link, that's very important, not only for the immutability, but also for more efficient backups and space savings. We're going to assign a drive letter through commands. We're going to add a new user service account, and we're going to assign them permissions. And with that, I think we should stop wasting time and jump right into the lab and just do it. So here I am again in the lab. For all my Whitesnake fans, got to have a little fun while we're doing these videos so we don't fall asleep here. So normally I would just come into my backup infrastructure. I would come to my backup repositories. I would add a repository, choose direct attached storage, and add my Linux or Windows server. But let's take a step back here. There's some additional things we need to do first in order to prepare this Linux repository for hardening. So I'm going to click the hamburger icon up here, and I'm going to scroll down to console, and I'm going to open up the putty utility here. Okay. Now it's asking for the host name or IP address of your machine, in this case our Linux repository. I am using Oracle Linux 8.2 or 8.3, I believe, and I'm just going to enter in my IP address. You can use your host name as well. Okay, and we're on port 22 for SSH, and I'm going to save this session as Linux repo. So let's save that. Okay. Now, when you save this, you may get a putty security alert that the host key is not cached in the registry. I've already ran through this a few times to make sure this video would be smooth as butter. So I've already done that. So if you do get that prompt, just go ahead and click yes. Don't worry about it. And then after that, what we're going to do is we're going to SSH into the server and pass the credentials. So let's do that. I'm going to select my repo here. I'm going to click load and open. Okay. Whoops. So here's our putty screen. Let me make that a little bigger for you. Okay. And we're going to start with the credentials of this server. you may just have root credentials or whatever you have specified. Then I'm going to do my secret password and enter. All right, so now we're ready to execute some commands with the SSH session. And we'll want to ensure that the newly attached disk is visible to the OS and available for use. So we'll use the iSCSI command for that and demonstrate a few options to check the storage. First, let's start with a clean blank slate. So I'm going to type clear and enter. Let's take a look at the disk information of this Linux repository, or Linux server as it is right now. And we'll do that with this simple Linux command of ls for list, scsci, so list SCSI, and then space dash s, so that we can see the size of the disk as well. Okay, so you can see here I've got a couple virtual disks. I can see the size of those disks as well. I've got a CD-ROM attached, right? Now, we'll want to take note of the disks that we're going to be using, the names of those. What you can also do is you can type the command ls for list and then blk for bulk, I believe, and click enter. And this will give you like a tree format of the disks and the volumes, logical partition volumes nested within the disk. Okay. This will reveal notable information, name, size, type, and mount point. All right. Now, in some cases, a newly attached disk may not be immediately detected, and a rescan could be required. There is a built-in shell script that makes this process very simple, and I'll show you what it is. I don't think I have any, but you may. So if you need to, and you don't see the disk that you've added to your Linux server, simply use the command rescan dash SCSI, SCSI, dash bus dot sh, and that big old enter button. Okay, and that's going to scan. As we can see, I don't have any additional disks. These have been here for a while, but if you do have one, it'll pop up there after a quick rescan. All right. So now that we know our disk is ready and we have its device name, let's create a new logical volume in the Logical Volume Manager, or LVM, and we'll apply a file system to it. Now, you could always format and partition a volume directly onto the raw underlying disk and forego using LVM. You may well decide that, hey, that's a better option for you. There are pros and cons to weigh, just like any architectural decision, so I recommend you do some additional reading on that subject. We don't have enough time to get into that today. After all, this is quick and nerdy. The main reason we're showing it here is that it's a good opportunity to get exposure on how logical volumes are created and managed, and it's more likely to be something that you would encounter in the wild or an enterprise customer, so it's worth knowing. So let's add our disk to LVM. To do that, we're going to type pv create space /dev /sdb enter. Okay, physical volume, the name successfully created. All right, and that is now a physical volume within the volume manager. And it's worth noting that partitions can also be used instead of adding the whole disk, but for this session, we will provide the whole disk to LVM. Now let's verify that our physical volume was created successfully using the PV display. So we're going to type PV display space /dev /sdb. And looks good to me. We've got about 40 gigs there. All right, now note that the volume is marked new unused and does not yet have a VG associated with it. We're going to talk about volume groups, or VGs, in just a moment. And to do that, let's create one. So we're going to do create space flex space dev space sdb. And that flex is just my own usage to identify that. Okay, so I'm just called that flex. That's not a specific command or anything. Now we always want to trust but verify, so let's verify that. We'll do VG for volume group, display space, and the name that you created. I just used flex and enter, and look at that. Volume group name flex. Some more information here. We can verify the size of the volume, right? We gave it the whole physical group. Now note that the number of current and active PVs in the volume group, as well as the total size of the volume group, in this case it's a single 40 gig disk, but if additional PVs were added, it would expand in size. Now to illustrate how LVMs can be carved up, let's add a new LV inside your newly created volume group. Okay, to do that, we'll type LV create dash dash size, we'll say 20 gigs, it's half, space dash dash, we'll give it a name, and I'm going to be real creative and just say Linux repo space flex. Okay, that logical volume was created with 20 gigs. All right, and let's check one last time just to make sure we know what we're doing here. LV display flex, okay? And we can see that logical volume has that 20 gigs there, okay? Perfect. So let's keep on moving. Now this is a very important part, and it's required. We're going to format this volume as XFS. So XFS is a file format for Linux specifically. It's the equivalent of Windows REFS, and it's going to give you space savings, efficient backups, write operations. I really encourage you to look more into XFS and the REF link capabilities that it provides. But it's also going to allow for the immutability. So this is a big one. Bear with me. Here we go. We're going to type mkfs.xfs space dash b space size equals 4096. That's the stripe size we want on these blocks. Dash, I'm sorry, space dash m space REFLINK equals 1, comma, CRC equals 1, space, backslash dev, backslash flex for the name of that volume volume, space, Linux repo for that virtual, that LV we created, sorry. And then we're gonna hit enter. All right, so I have cleared my screen and done a few things ahead of time to make this video flow a little smoother. But we're at the point where we've created the XFS file system with the REF link, and the last thing we need to do to bring this volume online is to mount it. And to do so, we're going to create a mount point. A mount point is a directory, and it will be added to the FS tab, which is the operating system's file system table, and that holds mount parameters and ensures our mount will be persistent between system restarts. So that way, if you restart your machine, everything will be in the same place. So let's make a mount directory first. So we're going to type in mkdir space backslash, and I'm going to call this Linux repo. And I'm going to hit enter. This will make a directory under the root directory with the name Linux repo that that's what I want to call it. Now you can see here, cannot create directory, Linux repo file exists. You should not receive this message. I'm receiving it because I've already gone a few steps ahead. You shouldn't receive any output or confirmation whatsoever. So to double check that it was created, just type ls space and then backslash, and that'll give you the list of the directories. So here's my Linux repo and everything I need to see here. There is a little bit more I could get into here, but you know, make this video as quick as possible, quick and nerdy. We're going to kind of just skip ahead to really get this done. We've still got a little ways to go. All right, now we can finally mount our Linux repo LV to our Linux repo mount point directory. And the way that we do that is we type mount space backslash dev backslash flex. Remember, that was the name that I gave the LV, slash Linux repo, which is the name that I gave my directory, space backslash Linux repo again. Enter. Okay, this will mount our logical volume device, which is dev slash flex slash Linux repo, to the new Linux repo location. Once again, you will not receive any output or confirmation unless there was an issue, similar to the way you see my screen. Yeah, if you want to make sure your file system was mounted, we can use the mount command. It's going to show you the, I believe it's pronounced grep, G-R-E-P. I'm not going to get into that either. I think that's getting a little too far into this. So let's just move on. At this point, we could start loading files on the file system. However, the mount would not persist through system reboots. So let's ensure it does by adding it to the file system table fs tab, like I mentioned a moment ago. Now, in order to do this, I need to have the UUID of our volume. And to get that information, I'm going to simply type in BLKID space backslash dev backslash flex backslash Linux repo, right? And I'm going to hit enter. There is my lovely UUID. And you can just click anywhere in the putty screen. It should copy that UUID into your clipboard. And now we are going to place the UUID into a shell variable that we can use in an upcoming command. So the command here is going to be capital F LEX, capital U UID, capital V AR. So that's capital for the F, the U, and the V, equals, and then paste in your UUID there. A right click should do it. And then hit enter. Okay. You shouldn't get any other confirmation. We're just putting that variable in. And now we're going to inject that variable along with some mount parameters into the file system tab that I mentioned. So we're almost there. Bear with me. We're going to type echo space parentheses all capital UUID equals $, bracket, capital F LEX, capital U UID, capital V AR, bracket, space, Linux repo, space XFS, space defaults, space 1, parentheses, space arrow, I guess. I forget the name of those. Space backslash etc slash fs tab for file system tab. Enter. Okay. Whew, so that was a lot, and there's a reason behind that, but we're going to kind of skip a lot of the explanation here. This is how we mount that. And let's keep on moving right along. So at this point, if we were to reboot our system, our file system should get remounted each time. Okay, so now onto the credentials, right? We're going to set up the credentials. So with the V11 hardened repository, there are two contexts that Veeam services will run under. A non-privileged service account that runs the data mover services that interacts with Veeam backup and replication during its normal operations. And there's a privileged root account that runs the immutability services that manages the immutability attributes of the file system. So we're going to create a non-privileged service account using the add user command. So right here, I'm going to type ADDUSER, add user, space, I'm going to say repo service. Okay, and enter. You again will not receive any kind of confirmation unless there was an issue. I'm going to skip the confirmation of that. We're just going to keep moving right along, assuming that we did that right. And let's also set a password. So right here we do PASSWD space REPOSERVICE for repo service. Okay, it's going to prompt us for the password for repo service account, and you can make your own password here. I'll pick mine on my side. Okay, it's going to ask you to retype it to confirm. Okay, once you got your password, we'll hit enter. Should get that authentication tokens have been updated successfully. Then let's make a new directory called backups in our Linux repo mount point from earlier. Okay, so this is all stuff that we're doing to the Linux server from our SSH rather than through a GUI or through the Veeam server. So mkdir space backslash Linux repo backslash backups, hit enter. You won't receive any outputs. I guess let's double check. We haven't checked in a while. Make sure we're doing this right. So let's type in LL space backslash Linux repo, enter, and you'll see backups has been created right there. Now, since we created this directory using the root account, it has default permissions for read and execute by other system users and lists root as the owner and root of the group. Let's change the owner of the backups directory to be repo service user and the repo service group, and then we'll see what's happened. So right here, I'm going to type CHOWN space repo service colon repo service space backslash Linux repo slash backups. Oops, make sure you spell that right. Backups. Enter. Okay, and we'll confirm with an LL space slash Linux repo. And the account now is repo service in the repo service group under backups. So we are good. Okay, so if you think about the flow of this, what do you think we need to do next? We've got the new account, the new folder called backups, but the permissions are still the same as before. So let's update the permissions so that only the repo service user account has access to the content of the backups folder. So right here, we're going to type chmod space 700 space backslash Linux repo slash backups. Enter. Right, and to verify this, let's type LL space backslash Linux repo. And I want you to take a look at the very far left. So if you look up above when we changed the service account, we had these permissions, WXR space or slash XR slash X, and now it just says WX. So the permissions are now just read, write, and execute, meaning the owner is the only one who can access the contents of the backups. At this point, we're ready to add our repository to Veeam backup and replication. So thanks for sticking with me through this putty where we're really doing this the long way, all through Linux commands. I think it's a very helpful task to do. But let's jump into Veeam backup and replication now that we're done here. And let's add that repository. All right, so just like any other repository, I'm going to go to backup infrastructure, add repo. It's going to be direct attached storage. It's going to be a Linux repository. I'm going to call this Hardened Linux repo. You call it whatever you like. Okay, next we're going to add a new repository. And remember the IP address or host name that you used earlier. Mine was 10.0.0.201. Okay, we'll click next. For the credentials, so we're going to click add, and this is really important. Make sure that you use single-use credentials for hardened repository. And the username that I chose was repo service, and my password. Okay, and I want to click elevate account privileges automatically. If it is not, in my case it already is. And check use suse if sudo fails. Okay, enter root password for your root account. Click OK. Click next here. It says, do you want to trust this server? Well, we just spent a lot of time building it, so I hope so. We're going to check that SSH connection. We're going to put our Veeam service in there and then get rid of those credentials. I'm going to pause the video for a second while it does this. All right, so that didn't take too long. Everything is done here. I'm going to click next. I'm going to click finish. Okay, so we got the repository added in. The next thing I want you to do is click populate, and we should see that volume we created, that Linux repo backups. See what we see here. Okay, and where is my Linux repo? Yep, that one right here, the 20 gig. Remember, this is the volume that we carved out of that 40 gig partition, right? We split it up. So we'll choose that one. We'll click next. Okay, now the last two things we need to do is we need to make sure that we're using fast cloning on XFS. Remember, we did create that XFS file system, and we did select the immutability policy. And so we can set our immutability to, however long we want to keep our backups. We'll say maybe you want ransomware protection for 30 days. And that is it. You next and finish through the rest of this. It's going to check to make sure those requirements are met. I think we did everything right. The rest of this stuff here is outside the scope, and this video is already really getting long-winded. So I do apologize that I couldn't squeeze this into my normal under 20-minute video, but I think hopefully this has been very helpful for you guys. You can see some other demos out there where we send a backup to this repository and we try to delete it, but that fails. You can also go back into your putty instance and you can see all the Veeam services running. But this should make you feel comfortable enough to create a Linux repository, harden it, immutability with the correct credentials and permissions, and protect your backups. So with that, I just want to say thank you. Thanks for spending the extra time today. I hope it was valuable. Hope you learned something. Don't forget to like and subscribe. We'll see you next time.